Good morning, ladies and gentlemen. Thank you very much for giving me this opportunity to speak to you today. I hope all of you are well and safe. Thank you, Nabil San, for inviting me here to give my perspective on simulation and testing. Let me start with a quote by Confucius. It says, "Our greatest glory is not in never falling, but in rising every time we fall." And so India has gone through a severe phase of COVID. We've had lockdowns, and this has severely impacted the Indian economy and has made us rethink and restart to see how we rise again. After the first wave, there has been a revival of sorts where the GST collections have gone up, the manufacturing has improved, the passenger vehicle recovery, in a sense, short-term recovery has happened. Of course, it has not gone to the 2019 level or to the 2018 level, but the economic activity has revived in a way. But the second wave has hit us the last 2 months, affected many of us in some way or the other, and especially and also the industry. So the impact of the second wave is yet to be surfaced. We're still in a phase where parts of the country are still in lockdown, and we are again looking at revival of the economic activity, and we hope going forward will improve. And what COVID has done is that it has thrown up a new normal. It has changed the way in which a human being, is doing his day-to-day work. Man is a social animal, and today we are all antisocial. We keep distance from each other. We don't visit friends and family. We work from home. We don't travel, and we are confined to the house. So in a way, it is a new normal, and it has given rise to what is the digital age in which everybody is connected in a way, but it's all done digitally. Of course, the COVID-19 has unique challenges and for India, because India is a very different type of country. And also from other perspectives also, India is very unique, has unique challenges. The fact that we have a low purchasing power, GDP per capita is 1/8 of a developed market. We have been working in high congestion on the roads. Of course, currently the density has reduced, but I'm sure when normalcy is restored, this congestion is something which we are all have to contend with. This has led to reduced speeds, rising emissions. Pollution is still remaining high. The import bill is high because most of our crude oil is imported, and we continue to have high road accidents, and India is number 2 in the world. But what is interesting and very different from India, another thing is that we have a very young population, and India customer is evolving continuously. And if you look at what they are looking for, there is an increased affinity towards modern technologies. They are always looking for intelligent features, whether it is on the smartphone or in other gadgets or in the passenger vehicles. They are always looking for enhanced safety. Safety has become very, very key for a buying decision. And of course, there is increased awareness in the current situation about health as well as hygiene. The regulatory trends are also are changing in a way that we are catching up with Europe. The emission norms of BS6 hit us in 2020 April, and auto industry has moved in 3 years' time, in a record time, to switch to BS6. And the auto industry is working towards the phase 2, which is in 2023, and CAFE phase 2, which is the current regulation. And of course, future is WLTP and Cafe 3 going forward. These are some things which are we need to continuously work on. Safety is become has become an important feature of the buy decision, and also the regulation is at par with Europe today. So frontal offset impact, side impact, ABS being mandatory, the passenger airbag has been made mandatory, and there are in future regulations like ESC and advanced driver assistance systems which are being discussed, and we are globally aligning, and this is forcing us to bring in new technologies, which is impacting cost, weight, and of course, we need to do this development. The other thing from a fuel efficiency perspective is in Europe, if you can see, in phase 2 in 2020, it is 95 gram per kilometer. And in phase 3, 2025, it is going to be 80. And then in 2020, in 2030, it's supposed to be 60 grams. What it is going to do is going to increase the electrification in a way, and battery electric vehicles, hybrid vehicles are going to be introduced, which is going to increase the overall weight of the vehicle by anywhere from 150 to 300 kilograms, depending on the size of the vehicle. These are required in order to meet the stringent CAFE norms. And as you can see, in 2021, the battery and plug-in hybrid technology penetration is slowly gaining traction in Europe. The other thing which the customer is today looking for is vehicle aesthetics, design. So exterior appeal is something which is very, very important. Interior design also is evolving, and infotainment system, the display audio, as well as the speedometer, these are all getting integrated, and we can see a lot of LED and also mode lighting and so on and so forth coming into the interiors. And so is the same is the case in the case of exteriors. You have LED lamps. The vehicles are becoming more aerodynamic because we need to get better fuel efficiency, and that's what the customer is looking for. And this is one change which we see going forward, and it is going to increase. The other thing is that new technologies are being introduced in vehicles. We are all aware that electrification is going to come in some time in India. But of course, we need to start working towards those technologies, which means that there would be battery technologies, also battery management system. We need to get the motor technology, the power electronics, and so on and so forth are going to bring in new design methods, advanced engineering, and new materials. Also, in the interior, advanced human-machine interface is going to come in, and in future, of course, they are talking about in Europe and USA, talking about autonomous vehicles. India, of course, is going to be very different as far as this particular part is concerned. We may not be going there in the near future, in the next decade, but surely in future we can also see such activity happening. So what is happening is that there are challenges, and there are opportunities which are there. So in short, consumerism is increasing, which is looking for appealing design, more comfort, safety features. Competition is increasing, regulations are becoming more stringent, and technological leaps are required in terms of electrification, connected technologies going forward. The challenge is, of course, the cost of vehicles is going up, the weight is going up, and the customer requirement is that the time to market for such technologies is reducing, and so customers are demanding this much faster. So we need to have a holistic approach to address the future vehicle requirements. The question is, how can it be achieved? So I will, look at the, model development approach, and this is something many of the engineers here would know, is the V cycle. So On the right side of the cycle, we are looking at development, we are looking at design verification physically, the requirement validation physically, and meeting the customer expectations. But increasingly today, we are now concentrating on the left side of the cycle. We are looking more towards the design, the modeling and simulation, and the concept and requirement stage itself. So in order to minimize the design effort towards the later stage of the model development, the focus is on to improve the left side of the cycle. How do we improve our concept and requirement from a customer point of view, from a usage point of view? How can we have use cases and models and simulation improve that design and have a kind of a concurrent evaluation as well as design to improve and optimize the design so that when we go into the physical prototyping, we get a good product going forward. So that's the kind of change in mindset which is required. And why do we need to do this? Typically, if you look at a model development cycle, it starts from concept, goes to 3D modeling, CAE, drawing, part and vehicle level testing, and then we go on to pilot and SOP. And typically, if you see, traditionally it is always that, we try to make the design, make the part, and then we do the validation, and then we do the changes, which is a very costly affair. So now all manufacturers are looking at, trying to improve the design much at the time of the drawing release. So what do? We need to ensure that this stage, the red line which is there, this big hump which is there, we focus on the design and concept stage. We also bring in advanced technology development. We ensure that the technology is developed. We validate using the CA simulation, and we build performance prototypes virtually so that when we get into the part and vehicle level testing, the effort required and is minimized, and the changes required post this is minimized. As I said, the conventional approach has been physical validation. The current situation is that we are looking at physical, which is physical as well as digital. But going forward, the future target is how can we make this laboratory come into the simulation? How can the road, actual road conditions, the actual lab conditions, how the physical testing, how can we build it into the simulation? So that's the change and that's the future target which we are all looking at. So conventional approach, design development, testing validation, and introduction of products. How can we change from this to improve the virtual simulation and do the front loading so that we can make the digital model stronger and better correlated to the physical testing. If you look at as far as all manufacturers are concerned, we are in a way matured our model as far as looking at various simulations which are concerned. We're not 100% as far as correlation is concerned, but we are quite there. So from a crash simulation, from a design and crash, there is a kind of correlation with the physical testing. Similarly, on the aerodynamics also, whatever the CFD analysis is throwing up and the wind tunnel testing, we are able to improve the model and come to a better simulation on the CFD. And also from a reliability perspective, I think we need to work a little bit more because the use cases are many. And how can we improve these models and build the reliability so that we can reduce our physical development, reduce our physical prototype, and be able to do this reliability analysis more in the labs or in the CAE is something which we need to do. And this computational evaluation for new product development is something which we are maturing. But what we need to see is that today we are able to do the weight and structure optimization. We are able to do the durability assessment. But going forward, the simulation landscape is going to change. Why I say that is because we are going to get into XCV technologies. and the design and development requirement is very, very different, and we need to understand it better. We need to enrich our model-based design, and more technologies, AR, VR technologies are also being built, and is something which we all need to, learn and improve. And the also from a testing and production variation analysis, we would like to make this more stringent. How can we, make vehicles which are having a lesser, variation as far as the tolerance is concerned? All of this can improve the durability, and this can also help in risk mitigation, elimination of design prototype going forward. I think that's what we are all looking for. How can we eliminate design prototypes going forward? Because it's a very expensive method of checking physical prototype, and elimination of that is something which all manufacturers are looking at. And what would that require? We need to have a higher correlation with the real world situation. And in order to achieve this, we need to have a better effectiveness of the design, digital validation, and this can actually result in a reduction in development cost as well as development time. Technology disruption is going to happen, and this is going to bring about a paradigm shift in the way in which we are going to think, and we need to do product development going forward. And just as an example, if you see the vehicle is going to have many engine controllers. They're going to be body control domain. They could be powertrain and XCV domain, the connected and infotainment domain, and they could also be advanced safety system, ECUs. All of these are need to talk to each other and how they are going to work together. And also, they also would need to talk to the infrastructure. And there would also be also some amount of connectivity is going to be there from the infrastructure into the vehicle also. So it is going to be both ways. And so this is going to, bring about a lot of challenges for the product development. So we need to have more robust performance. There will be multiple functions, use cases which are going to be there. We need to ensure that all these talk to each other in a way. We need to have security of data communication and advanced, graphic user interface. So many challenges are going to be done, and all these require a different kind of mindset and change as far as the way in which we are going to evaluate the product is going to be concerned, both physically as well as digitally. So there is going to be, because of the increased controls and software content, the reliability is becomes more challenging in such future technologies, and we need to learn this level of simulation going forward and build up use cases, build up the models, so that we are able to correlate with the physical and improve the math model going forward. Again, if you look at the V cycle, the V cycle becomes even more relevant in this case, because each of the technologies at the unit development level has to be also ensured that it is robust and reliable. And also as a system, when we put it on the vehicle, they also become more reliable. So we need to front load the evaluation. So vehicle in loop and system in loop on the left hand side of the cycle, they need to front load this evaluation through advanced system validation and model in loop and desktop simulation. This kind of a simulation kind of thinking we need to build into the V cycle going forward, so that these advanced technologies which we are having, we are able to further front load these technologies into the vehicle development process. And especially when we look at electric, connected and infotainment kind of and advanced driver assist systems, the methodology and the math models and the kind of model in loop and the system validation which we need to build is going to be much more complex. And these strategies we need to develop going forward so that we can have a robust product development. And so when we actually do the physical validation in system in loop or vehicle in loop, we are able to ensure that whatever the designers had thought of from a concept point of view or from a design point of view, the actually it meets the requirement of the customer. So that's something which we need to continuously work on. Also, when we are looking at the future technologies, when we are looking at hybrid technologies, we are looking at electric vehicles. There will be a lot of work which we need to do in terms of safety and crashworthiness, because the platforms will be different. The battery pack is going to be built under the under the floor, which would require more robustness, both from the side impact and rear impact, as well as the frontal impact. And the battery also, the safety cage has to be very robust. The motor cradle has to be, the durability has to, has to be very good. Similarly, from a motor also, and the battery pack, those simulations we need to, further, develop and work on. And similarly, the battery pack and the thermal management system, these need to be, further have to be made robust. So all of this is, also building in a lot of challenge in terms of weight and complexity. So we need to have effective, simulation tools on the NVH side: performance, durability, safety, and thermal, etc., in order to meet these future design validation requirement, because that's how the simulation landscape is going to change going forward. Future approach for simulation technologies, we need to also look at more robust simulations, use the AR and VR techniques, which will be required, so that lesser physical prototypes are there, and we are able to judge more of it digitally, and the engineers is able to visualize through these VR systems and be able to design first time right, reduce the development cost as well as time, and address the future complexities of new powertrains, XCV technologies, and advanced materials. What this means is that we need to continue to our work on looking at advanced materials, design optimization, and this lightweighting is something which we need to continue to work. And today also, all engineers are given targets as far as weight is concerned, cost is concerned. That is not going to change. That is only going to become more challenging and more important. So engineers will have to look at newer materials, look at composites, look at polymers, look at ultra high tensile steel, maybe look at aluminum, and do the change as far as materials is concerned, material substitution to reduce the weight and improve the performance. So some of the things which are happening is, in case of Maruti, is, the fuel box is made from sheet metal to plastic. The manifolds have changed from die casting to composite. So these are things which we are working already. Also on the platform technologies or a hard tech platform, we are using more high tensile steel, making the platform weight change, reduce. Also, from the previous generation to the next generation of vehicles, there is a substantial weight reduction which we are targeting going forward. And we are also trying to look at improving the aesthetics, reducing the CD or the road loads, improving the touch and feel in the interiors, and improve the safety and features. All of this requires that we need to have advanced materials, and we need to make the design overall more robust and efficient. So the future approach for as far as simulation requirements is concerned is we need to develop new materials, and we need to develop more new modeling tools, develop the material characteristics, build it into the model so that we are able to predict. Second is we need to upgrade our simulation tools so that we can correlate the local load cases or the use cases. Three, we need to look at simulation methodologies to validate performance for future technologies like XCV technologies or infotainment and future safety requirements. We need to have a good computational lab and hardware system so that we are able to get a good correlation between the computation and the actual physical testing. And lastly, and the most important is, how do we develop engineers who have the mindset to be able to develop capability to check for functional requirements and also look at front loading and looking at the possible use cases and see at the design stage, how can you front load these technologies, these requirements into the design and the validation requirement, so that the physical testing requirements is gives better results and also reduced. So our attempt is to get better results in the or the as envisaged in the design at the time of physical testing, and ultimately to reduce the physical testing and go more towards the simulation technologies going forward. I think that's the way forward as far as the industry is concerned. In order to do this, one other thing which we require to do is that the OEMs need to have a work in a collaborative atmosphere. It is not one area which can work. We need to work as OEMs with material suppliers to look at new materials and new technologies for manufacturing also. We need to work with simulation and testing agencies to work on such new simulation tools. And we also need to work with the software developers to make the engineering simulation more robust, so that we can bring the road and the labs into the CAE process. And this collaborative effort is required to meet the future requirement. And of course, all of this requires a skill set. The engineers need to develop this kind of a skill set and look at more innovation going forward, so that we can improve our overall process and make it robust. So I think very importantly, as India, we need to look at how we can do India-specific research and development, develop indigenous technology and manufacturing, and of course, we need to scale up whatever we are doing, so that we can, deliver products as required by the customer. So I think there is a lot of opportunity, and I'm sure the conference is going to have a lot of discussion around the simulation and technology, and how we are going to develop new materials, how we are going to look at new methods, how we are looking at newer ways of improving our development process, make it more robust and make it relevant and provide more value to the customer. So thank you very much for your patient listening, and I'm sure you will have good deliberations in the conference today. Thank you very much for your patience.